Hi guys, welcome to Science in 5. In this video we're going to discuss calculus, an introduction to calculus. This word calculus sounds very weird and very complicated, It's like in primary school you're talking about maths in terms of numbers, 1 plus 1, adding numbers. Then you go to high school, there's a word algebra. Now everything seems complicated. Now there's another word, calculus, that's added in. It's interesting that this field of maths was actually designed by guys who were into physics and science. They wanted to calculate the average gradient, of graphs like this, or the gradient at any point, rather. Okay. Now there are two branches of calculus. One of them is integral calculus. The other one is differential calculus. Differential calculus is concerned with rates, optimizations, things like that. Integral calculus is concerned with volumes, areas. Okay, we are going to focus on differential calculus. Now, the basic thing of differential calculus that you always talk about is the derivative. If you know how to get a derivative, then basically you're sorted with calculus. So you know how to get a derivative. How does this concept of a derivative work? Well, let's start by looking at this graph. F of x equals x squared minus 4x minus 5, right? If I was to work out the gradient between x equals 0 and x equals 5, I could work out an average gradient, right? How would I work out the average gradient? I would use the gradient formula. M equals delta y over delta x. Now, the change in y over the change in x. So this point here is now 5, 0. This point is 0 minus 5. So y2 minus y1. So if I take this as my y2 value, this is the same as 0 minus 5 all over 5 minus 0. I get a gradient of 1. Okay, yeah, makes sense. What if I wanted the gradient of a point? Like, let's say there's a point here. All right, let me just remove that quickly. What if there's a point here? I wanted to measure the slope. I can't see any change in y or x. So would I say the gradient is 0 at that point? Not necessarily. If I was to look at it this way, we know that lines that move like this have got negative gradient lines. So the gradient is negative. Then it slowly loses its negativity, becomes 0, starts getting positive, and it somewhat starts to increase. So the gradient at this point is not 0. How I can solve this problem of getting the gradient of that point is, what if I choose two small points, very small points. Let's say at this point, that's the value x. Then at that point, it's going to be x plus h. So h represents a little change along the x, very small change. Then at this point, I'm going to have f of x, the function value when the input is x. Then here, I'm going to have the function value when input is x plus h, like that. Okay, so I can work out the gradient by using the gradient formula, all right? So then I'll come and say, well, gradient is change in y over change in x. Now, the change in y is going to be, let's say that's my y2, that's my y1, that's my x2, that's my x1. So it's going to be f of x plus h minus f of x all over the x plus h minus x. This then simplifies to f of x plus h minus f of x divided by h. Now, if we shrink this h to 0, make h as small, approach 0 as much as possible, then it means we have got a formula to calculate the gradient at that point. So this formula becomes the limit as h approaches 0, f of x plus h minus f of x all over h. Now we call this first principles. So you will come across word that says, use the first principles to get the derivative of that. Using the first principles. It basically means use this formula. the derivative is f of x plus h minus f of x all over h. So this formula allows us to get what is called a derivative. Guys, the derivative is the basics of differential calculus. If you want to make your life easy with differential calculus, know how to calculate the derivative. Okay. Now, this formula, we use this notation f prime of x, like that. This shows us that we need to calculate the derivative. Okay. Later on, we're going to talk of other notations that are also used that relate to calculus and calculating the derivative. So that's it about the derivative, first principles. What does that mean? Thanks for watching, guys. In the next video, let's use this idea of first principles.